Hello everyone. Today let's solve the Leetcode problem number 105. Construct binary tree from preorder and inorder traversal. Right. So what the question says, given two integer arrays preorder and inorder, where preorder is the preorder traversal of the binary tree and inorder is the inorder traversal of the same tree, and return the binary return the binary tree, right? So example 1, they have given 3, 9, 20, 15, 7, nothing but the output they have showed. So preorder of this one is, preorder starts from root left and right, nothing but 3, 9, 20, 15 and 7. This is preorder, not the inorder. Root left and right, 3, 9, 20, then 15 and 7. This is going to be the preorder. Inorder is nothing but left, root and right. So again I am telling left, root and right, nothing but 9, 3, 20, 9, 3. So here we have 15, 20 and 7. 9, 3, 15, 20 and 7. So that's what they have given here. Totally we have to return 3, 9, 20, 15 and 7, right? The output has to be. So what we are doing here initially, just give me a second. So what we are doing here, initially the preorder is this one, right? Inorder is this one. So initial call will be root 3, this one. Initial call will be root 3, the element of preorder, nothing but this one. We are splitting inorder at 3. Again I am telling we are splitting the inorder at 3, this one, right? So basically what they have shown. So left will be 9 and right will be 15, 20 and 7. This entire thing. Right will be 15, 20 and 7. So now let's come to the left of the subtree. So now the preorder is 9. This one, second step. Now the preorder is 9 and the inorder is also 9. So preorder is also 9, inorder is also 9. Why preorder and inorder both are 9? We are taking the root 9, considering the root 9 because right, we don't have the right and the left subtrees. This is null and this is also null, right? So here we are having only one element, that is nothing but 9. So in the third thing what we'll do, we'll come to the right subtree. So we have considered root, this is fine, this is over, and the second step 9 we considered, this is not having the left and right subtree, so this is over. In the third we are considering the right subtree, nothing but right subtree of 3, nothing but 15, 20 and 7. This entire thing that I have marked, right, starts from 15, 20 and 7. So basically what we are doing here, the preorder will be basically 15, 20 and 20, 15 and 7, right? So and inorder should be 15, 20 and 7. Preorder is root, this one, left and right. Preorder is 20, 15 and 7, and inorder is 15, 20 and 7. So we are splitting the inorder at 20, right? We are splitting the inorder at 20 because this is the root we have got. We are splitting the inorder at 20. So left will be 15 now and the right will be 7 now at the third step, right? Now we have both the left and right subtrees are this one. Split the inorder at 20, left will be 15 and 7. Next let's come to the fourth step. Fourth step is what we have 15 and 7, right? So preorder is 15 and inorder is also 15. Why preorder and inorder both are 15? We don't have the values here. These both will be null, right? And the subtrees for 15 will be null. So root will be 15 in this case, in the fourth step. So both left and the right subtrees are empty since it has only one element now in the first step. Next, so we will move to this one, right subtree 20. So we are considering the right subtree of 20. Preorder will be 7. So this one we will come to the right subtree is nothing but we are considering this itself, right? So we are considering the right subtree of 20, nothing but the 7 in the fifth step. So now we are in the fifth step. here also we don't have any value, right? We don't have the left subtree and we don't have the right subtree. This both will be null basically. So preorder will be 7 and inorder will be 7. So root we are having is 7. Here in the fourth step, root we were having was 15 and the root now we have is 7. Both the right and left subtrees are empty since there is only element. Now the final structure that we got is initially 3. Second step we considered 9, right? We didn't had any values. So we considered 9. So next we didn't had any value for the 9. So we moved to the right tree. So it was 20, right? So it was 20. Next, in the fourth step, we had only 15. That is nothing but the left tree of 15, left subtree of 20, and the right subtree of 7 was this one, fourth and fifth step, 15 and 7. So it has to be 20, 15 and 7, right? So total we can write 3, 9, 20. This one we are having null. This one will just give null and null. In this case, I'll just give n. So this will be null. This will be null. And finally, 15 and 7. So that's what we got in the answer. Nothing but this one. It is not visible. Let me delete that one. This one. Yeah. 3, 9, 20, null, null, 15, 7. That's what we got in the example, right? So let's see how can we, let's continue by writing the code. I'll just delete this one. Let me close this. Yeah. Initially what I'll do, just give me a second. Let's consider the base case. If preorder array is empty, right? This one. Preorder array is empty, then we'll return null. Why we are returning null? We are having no tree to build, right? So we'll just return null. That is nothing but the base case. I'll just consider if condition. If preorder, the length of the preorder, then we will return null. Next, let's find the index of the root in the inorder array. Finding the, what we are finding? We are finding the index of the root in the inorder array. So how can we find the index? I'll just take the variable name index. I'll give inorder. I'll just make use of the index of function, inbuilt function in the JavaScript, right? So I'll just give preorder of 0. That is how we considered 3 initially, right? The first step, if you remember. So next, we are recursively building the left subtree using the left part of the preorder and inorder arrays. So I'll just give, in my case, left equals, let's make use of the, we're making use of the recursion, right? Recursive function. I'll just copy this one. Let me paste it over here. This will be preorder dot, let's slice from 1 index plus 1. Next, what we are doing, inorder slice, what we are slicing from 0 to index. So if you know the slice, you will understand what we are slicing, right? So next, what we are doing, we are recursively building the right subtree using the right part of the preorder and inorder arrays. Nothing but here, what we did, we recursively, we built the recursive. We recursively built the left subtree using the left part of the preorder and inorder arrays. Next step, we are doing nothing but recursively building the right subtree. First, we did for the left subtree using the left part of the preorder and inorder arrays. Now we are doing for the right subtree using the right part of the preorder and inorder arrays. So I'll just take here itself. Sorry. Let me give let right equals. Yeah. Let me paste the function here. Recursive function. Build tree of preorder dot slice of index plus 1. Again, in order of same. here we took index plus 1 and index plus 1, 0 and index. Here we are taking index plus 1 and same index plus 1, right? So I'll just give index plus 1 in this case. So this should be clear. And finally, what we are doing, we are creating and returning the root node with left and right subtrees completely attached. We have to get this in this format, right? So that's why what we are doing, we are creating and returning the root node, initial node with left and right subtrees. So we have to get in this form. So that is why we are creating and returning the root node with the left and right subtrees attached. I'll just give return within the flower braces value. I'll take preorder of 0. Also left and right subtrees also we have to consider along with the root node, right? So I'll just take preorder left and right. So in simple terms, we have considered the root, then left and right, we are performing the recursive functions on left and right. So after doing this one, we are getting the entire this thing, right? We are getting this value. That's what we are doing in simple terms. So let me format this code and hit the submit. So yeah, what am I getting? Index is not defined. We have not defined the index. Just give me a second. So here it has to be, I just wrote like, this has to be index, right? So let me hit the submit again. The part Inorder is not a function. Line number 7. So this has to be inorder.slice. So I forgot slicing here. So this is fine. Again, let me format and hit the submit. So yeah, now this works properly, right? So what will be the time complexity and the space complexity? So here, what we are doing, we are each call to the build tree, this one, each call to the build tree processes the preorder and the inorder arrays and finding the index and inorder takes basically big of n time. So we are having n nodes, right, totally, which will lead to big of n recursive calls. We are making the n recursive calls. So hence the overall time complexity would be big of n to the power of 2. So I'll just come here, I'll just give n to the power of 2. And space complexity would be mainly due to the recursion stack. We are finding the space complexity, right? In the worst case, the recursion depth can go to up to n. So we are also making use of slice, right, here. Additionally, slicing of the arrays creates new arrays contributing the space usage. So the space complexity would be big of n to the power of 2 as well. We are making use of the recursion stack as well as we are making use of slice. So the overall space complexity would be big of n to the power of 2. So yeah, this is it. Let me comment this one. Yeah, this is it. Thanks for watching, guys.